Hello students, this is Ankit Joshi. I welcome you all on India's largest e-learning platform BYJU'S Exam Prep. And in today's session, we are going to discuss a very important topic from probability, what is called as Bayes Theorem and total probability. Students, I'm not going to take much of your time. Within 40 minutes, I will be giving you the entire concept of total probability and Bayes theorem. And I believe that this is one of the most tedious concepts of probability. Yes. So students, let's start Bayes theorem and total probability. This is a brief introduction about me. Students, on your screen, you can see the brief information about me. That I have been teaching in this GATE ESE domain since many years, and my subjects of interest are engineering maths, signals and system, and analog circuits. So these are my subjects of interest. I request all of you to hit the like button. And those who are online here, can you show your presence with the help of some comments, some symbols, some hearts, whatever you wish. We need your presence. We need your presence in the comment box. Can I have your presence? Can I have your response? Yes, please. I can see Tezuram, Pratiti Pandey. Apart from these, yes, who all are there? Can you please respond? So, students, what you can see on the screen, GATE Aimer series. Already, every day I'm announcing that from 14th of November, we have started a crash course here on this YouTube channel. Yes, this crash course is available for EC, electrical instrumentation and computer science. I request all of you to just follow the classes for your best revision. Students, one very important announcement for you. On your screen, you can see your favorite, yes, civil champion, Abhinav Negi sir. So he will be coming live at 8 p.m. today. That is on 19th November. Today, remember the time, 8 p.m. Where he will be coming live? He will be coming live on BYJU'S Exam Prep app. Yes, that is our app. That is our app, and you can follow his strategy to crack GATE. Yes. And another announcement is we are having some mock tests that are again scheduled on our app. And students, you need to download BYJU'S Exam Prep, and then you need to enroll yourself for this test series. So these mega mock tests are available between 15th November to 22nd of November. When we talk about total probability and Bayes theorem, actually we are talking about some unorganized probability. So students, unorganized probability starts with the concept of events. So we have got 4 different types of event. We will go through them one by one. You can see here, mutually dependent event, mutually independent event, mutually exclusive event, and collectively exhaustive event. We will go through them one by one. Mutually dependent. See here. Students, please concentrate here. We are having a big premises. हमारे पास एक बड़ा सा premises है. In this premises, the entry gate is named as A. There is another small room in this premises whose entry gate is named as B. So there is a big premises whose entry gate is named as A. There is a small room inside this big premises whose entry gate is named as B. Okay, now if someone is here inside this small room, then what should be the flow? First, this person has to enter from gate A, and then he need to take entry from gate B. Is it possible for this person to enter gate B without entering gate A? Is it possible for this person to take the entry from gate B without taking entry from gate A? Of course not. Of course not. So what we can say that B is dependent on A. 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 B क्या है? B A पर dependent है. B is dependent on A. On the other side, A is not dependent on B. A is independent of B. In this context, by observing the diagram, we can say that A is not dependent on B. A is not dependent on B. So clearly we can say that we are having two events A and B. Hello, we are having two events A and B, where B is dependent on A, but A is not dependent on B. But still, in the context of probability, we say that A and B are mutually dependent. What you will see, what you will get in the question, A and B are mutually dependent. They will mention that A and B are mutually dependent. Now, one of my advice for you, whenever you get this clause in any of the question, A and B are mutually dependent, then you can self-realize that out of these two, one of the event will be dependent on the first one and the another one is independent. After reading this statement, you can just conclude yourself that out of A and B, one of the event will be dependent and another event will be independent. Now, which one is dependent and which one is independent, that will be known to you only after going through the question. Okay, so by clearly understanding the context of the question, you will come to know that out of this A and B, which is dependent and which one is independent. Just by observing this diagram, you can say and conclude that event B is dependent on A, but A is independent of B. Is that clear? Now, if A and B are mutually dependent, then we are interested in their joint probability. What is their joint probability? Probability of A intersection B. इसको क्या पढ़ सकते हैं आप? This is joint probability of A and B. Joint probability of A and B will be probability of A multiplied by probability of B. Probability of A. A is the independent event. A is the independent event. So its simple probability P of A will appear here. And then probability of B. Since B is dependent, so conditional probability of event B will appear here. Probability of B. Conditional probability, how we are going to represent it? Conditional probability of B given that A has already occurred. So this is how you are going to write joint probability as the product of a simple probability and a conditional probability. What is this? This is joint probability of A and B. क्या है ये? Joint probability of A and B. Joint probability of A and B. What is this P of A? Simple probability. Simple probability किसका होगा? Whose simple probability you are going to write? We are going to write simple probability for independent event. So P of A. This is also called as marginal probability of A. Marginal probability of A. What about P of B given A? P of B given A. Conditional probability of B given that A has already occurred. Conditional probability of B given that A has already occurred. Is that very clear? Is that very clear? Come on. If I just change the scenario of A and B, if I just change scenario of A and B, this is the big premises. Whose entry gate is named as B. There is a small room inside it whose entry gate is named as A. If someone is here, then we can say that this time A is dependent on B and B is independent of A. B क्या है? B is independent. Now, if you are interested in the joint probability of A and B, this will be marginal probability into conditional probability. Hello, joint probability is always the product of a marginal and a conditional. So this is joint. So marginal probability of the independent event. यहाँ पर out of this A and B, which one is independent? Independent is B. Sorry, independent is B. Yes. So marginal probability of B multiplied by conditional probability. Whose conditional probability will appear over here? Of A given B. So ultimately we can say that joint equal to marginal into conditional. Joint equal to marginal into conditional. So whenever you have mutually dependent events, then joint probability of those two events will be marginal into conditional. Whose marginal probability you are going to write? Marginal probability of independent event. Whose conditional probability you are going to write? Conditional probability of the dependent event. Can I have your response? Now, mutually independent. Mutually independent. See here. If A denotes getting head on coin toss and B denotes what? B denotes getting number 3 on die toss. So students, when you toss a coin and a die together, when this coin and die is tossed together, then joint probability of A and B. One simple question to you. Is the probability of A going to affect B? No. Does vice versa exist? Good evening, bacha. So getting head on coin toss is not affecting getting 3 on die toss, and vice versa. Getting 3 on die toss is not affecting getting head on coin toss. So ultimately P of A intersection B will be P of A into P of B. P of A intersection B will be P of A into P of B. Is that clear? So whenever you have mutually independent events, then joint probability will be just equal to the product of marginal probabilities. Joint probability will be equal to the product of marginal probabilities. Is that clear? Mutually exclusive. Suppose event A is getting head and event B is getting tail. So if you talk about an event in which A and B occur simultaneously, just think, is it possible to have head and tail simultaneously on the same coin? Is it possible? No, sir. So this is an impossible event, so its probability will be 0. So whenever you have mutually exclusive events, when event A occurs, B will not occur, and when event B occurs, A will not occur. So joint probability of A and B will be 0 in this case. Hello students, can you all hear me all? I hope so. So there was some server issue, maybe connectivity issue as well. So we just rectified it. Is it all fine? Am I audible to you? Can you all hear me? Can you please respond? Thanks a lot. Thank you so much. Just a moment, just a moment. Shall all set, all set, ready to fire again. So we have got two events A and B. We'll repeat this. Maybe you would have missed out this one. We have got two events A and B which are mutually exclusive and collectively exhaustive. A and B कैसे हैं? Mutually exclusive means when A occurs, B will not occur, and when B occurs, A will not occur. Collectively exhaustive means sum of their probabilities is 1. Addition of their probabilities is 1. Now, these two are the events. There is another event E. There is another event E which can occur either through A or through B. There is another event E which can occur either through A or through B. So can we say that event E is dependent on A? So when event E is occurring through A, then A will be the independent event and E is dependent on A. When event E is occurring through A, then event E is dependent on A. Therefore, A is the independent and E is dependent. So for A, there is marginal probability and for E, there is conditional probability. Similarly, when event E is occurring through B, then B is independent. So marginal probability for B and conditional probability for E. Okay. Then we have at this position, event E has already occurred with the help of A. So probability of E intersection A. And here we have probability of E intersection B. So probability of A into probability of E given A. अरे भैया joint probability equal to marginal into conditional. Joint probability equal to marginal into conditional. Similarly here, joint probability equal to marginal into conditional. Just go through it once and let me know you understood this or not. All right. So students, probability of occurrence of event E. This can be done in two ways, either through upper path or through lower path. So this will be P of E given A, sorry, P of E intersection A plus P of E intersection B. So P of E will be this or this, first or second. So first plus second. So this probability P of E is called as total probability. This P of E is called as total probability. Now once again, we have got two events A and B. There is another event E which can occur through A or through B. So probability of E given A, probability of E given B. Here we have marginal probabilities P of A and P of B. So at this position, we are saying that event E has already occurred. Event E already occur हो गया है. Event E has already occurred. What is the probability that it occurred via A? Event E has already occurred. What is the probability that it occurred via A? Similarly, here, event E has already occurred. What is the probability that it occurred via B? Okay, so these two probabilities. So this is nothing but a conditional probability. We are having a formula. Joint equal to marginal into conditional. So conditional will be joint upon marginal. So joint of these two, P of E intersection A upon P of E. joint of these two. So P of E intersection B upon P of E. Comfortable? So these statements are nothing but Bayes theorem. Comfortable? Just remember these ones. Next. See this question, students. Consider two boxes, box 1 and box 2. Box 1 contains 4 red and 6 black balls. Box 2 contains 5 red and 5 black balls. Okay? Now, a coin is tossed. You are tossing a coin. Now, a coin is tossed. If head occurs, then one ball is randomly drawn from box 1. If head occurs, then one ball is randomly drawn from box 1. If tail occurs, then one ball is randomly drawn from box 2. This is the scenario. Okay, they are asking for what is the probability that the ball obtained is red. They are asking for what is the probability that ball obtained is red. Here, they are not directly picking the balls from the box. They are first tossing a coin, and depending on the outcome of the coin, they are selecting the box and then randomly drawing a ball from that box. It means it is a two-level event. So this is nothing but total probability. So students, I will just arrange this beautifully in another diagram. See here. This is selection of box 1 and this one is selection of box 2. Selection of box 1 is nothing but probability of getting head. And selection of box 2 means getting tail. Then what? Then we have box 1, from box 1 getting red ball. Red ball can also be obtained from box 2. Anji. So probability of box 1 is already selected, getting a red ball from box 1. Box 2 is already selected. What is the probability of getting red ball? So students, from box 1, what is the probability of getting a red ball? So from box 1, probability of getting red ball is 4 by 10. 4 by 10, yes? Box 2, probability of getting a red ball from box 2, 5 by 10. Now see here, at this position, we are just writing the joint probability. Probability of R intersection B1 and probability of R intersection B2. So joint will be marginal into conditional. Hello, marginal is 1 by 2, conditional is 4 by 10. Here also marginal into conditional, 1 by 2 into 5 by 10. Calculate this. Four by 20. This one is 5 by 20. Comfortable everyone? So first question is, find the probability of getting a red ball. So probability of getting a red ball. Either the first part or the second part. So addition of these two. 9 by 20. Suppose red ball is already obtained. What is the probability that it came from box 1? Red ball is already obtained. What is the probability that it came from box 1? This is joint upon marginal. Red ball is already obtained. What is the probability that it comes from box 2? So this numerator is 4 by 20 upon 9 by 20. So 4 by 9. Then R intersection B2 is 5 by 20 upon 9 by 20. So this will be 5 by 9. So this last two results are the outcome of Bayes theorem, and the first one is the outcome of what? First one is the outcome of total probability. Comfortable, everyone? All of you understood? Have you all enjoyed this concept? See, in a board factory, machines A, B, and C are there. In a board factory, machines A, B, and C manufactures 25%, 35%, and 40%. Okay. तो मशीन A 25% प्रोडक्शन को कंट्रीब्यूट करता है, 0.25, then 0.35 and 0.4. There is a you can just try this question as homework. Okay, we'll connect in the next class. Thanks a lot. Thank you all for coming to this session.